Hello and welcome to this quick Internet of Things demo in the context of patient-generated data. And my name is Kevin, and before I describe to you the hardware that you see on the screen, let me give you a use case and help motivate this demo along. As we know, healthcare and medical providers are increasingly pressured to reduce their costs. One of the ways that we can achieve that is to limit the overall number of patient visits to their services, and at the same time, improve the overall outcomes of the patient experience. We can do that by treating the patient, rather give the patient a FitBit device or some other activity health tracking device, so when the patient leaves the facility, they can continue to monitor the patient. How many steps are they walking? How many floors are they climbing? This data has to be seamlessly synchronized to the medical systems, of course. The problem is a little more complicated in that they can't just give them the FitBit device and expect them to upload the data via their computer or home desktop. Furthermore, this communication is not just a one-way communication. It's a two-way communication because the medical staff may want to monitor this data and change the goals, tell the patient to walk more steps or take less floors. They may want to set alarms or even send alerts. All these devices come with silent alarm capability. They could set a reminder alarm, for instance, of a certain medication that must be taken at a specific time. So what you see here is a FitBit device, a Bluetooth dongle and the USB port, and the cabling winds around here into the Raspberry Pi device. So how does all this come about? Well, the solution has to be low cost, not just the hardware talking about, but also the messaging fabric that is used to communicate all these events back to the cloud. The data has to get back to the cloud. That has to be affordable as well. So just to play out this use case, continue with the demo, you set the device in the family room or kitchen or somewhere where the patient walks close to the device. It reads the data from the FitBit activity tracker and sends it into the medical service. For instance, the medical personnel, via this kind of small example of what we're demoing here, of platform of devices and events, could change the goal or alarms for those that they are monitoring. And all this, again, communicated back to the Raspberry Pi device, and then the Raspberry Pi syncs up with the FitBit device. Okay, so now I'm in my profile, and you can see yesterday I did 6181 on steps, and I'll just click today. So far the cumulative total is 203 steps. And let me check in here with my Fitbit tracker, and I'll flash that here, let the camera lens catch up. And on focus here, let's see, okay, 203. Great, so let me just leave here and walk around my room here a little bit. And boom, 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 I come back in, 236 steps. Again, we'll flash that on the lens here. The camera will pick it up. And what I want to do is go and now refresh. And it should have already synced up. And so as it refreshes, we'll see great. Now my dashboard comes up and you'll see that, okay, great, 236 steps. And let me check back in with my Fitbit and we're still at 236. Good. Let the lens catch up. There you have it. So that gives you an idea here with the dongle refreshing and sending the information back up. So that's the overall idea here in the demo that we just threw up in the Internet of Things, and the type of things you can do with devices such as the Fitbit or any other health and activity tracking device and the API that they provide, including something like a Blue Energy dongle, which we've shown here, the Azure Service Bus, of course, which is a public cloud messaging infrastructure. So I hope you enjoyed it, and please give us a shout if you have any questions. Thanks.